Okay, children. So we'll discuss definitions from periodic classification of elements. Periodic classifications of elements, children, 10 series. Periodic classification of elements. From this lesson we will see. First one. First definition, children. Okay, first definition, most important definition. What is periodicity? So many times in board exam they ask children, what is periodicity? Repetition of properties of elements at regular intervals. Repetition of properties of elements at regular intervals is called periodicity. Repetition of properties of elements at regular intervals is called periodicity. Repetition of properties of elements at regular intervals is called periodicity. Some examples like how atomic size changes in group and period, how metallic character changes in group and period, how non-metallic changes in group and period, how valency changes in group and period, how reactivity changes in group and period, how ionization energy changes in group and period, how electron affinity changes in group and period. So many I discussed. We have videos also. Periodicity is what, children? Anyone? Can anyone repeat the definition?
Repetition of properties of elements at regular intervals.
Very good. Repetition of properties of elements at regular intervals is called periodicity. Next, Dobernier's law of triads. Dobernier law of triads. Yes, children, what is Dobernier law of triads?
It's an increasing order of their atomic mass.
Well, elements are arranged in
Increasing order of their atomic weight.
Increasing order of their atomic weight, and elements are arranged in increasing order of their weight. Then
an average of first and last element gives the mass atomic weight of middle.
Average of first and third element. Okay, if the average of first and third element, if the average of first and third element gives atomic weight of middle element, gives the atomic weight of middle element, that three elements will have
same properties.
That three elements will have same properties. That three elements will have same properties. Okay. Compulsory you have to give example whether they ask or not. Lithium, sodium, potassium. This is 7, this is 39. 7 plus 39 is how much, children? 46. 46 by 2 is how much, children? 23. If they have like this property, then the three elements are said to have same properties. If any three elements satisfy this condition, the three elements will have same properties. If any three elements satisfy this condition, the three elements are said to have same properties. Okay, children? Next one. Newland law of octaves.
When elements are
arranged in increasing order of their atomic weights, then every eighth element is the repetition of its first element in its properties.
Very good, both of you. When elements are arranged in increasing order of atomic weights, when elements are arranged in increasing order of atomic weights, when elements are arranged in increasing order of atomic weights, every eighth element is
repetition of its first element.
Repetition of its first element. Repetition of its first element. Repetition of its first element in its properties. In its properties. Repetition of first elements in its properties. Repetition of first elements in its properties. Okay, so next. Mendeleev's periodic law.
Physical and chemical properties of elements are periodic functions of their atomic weight.
Very good. Physical and chemical properties of elements. Physical and chemical properties of elements are periodic functions. Periodic functions of their atomic weights. He arranged elements in increasing order of atomic weights. No? Physical and chemical properties of the elements are periodic functions of their atomic weights. Physical and chemical properties of the elements are periodic functions of their atomic weights. Underline atomic weights. Next, Moseley's or modern form of periodic law. Moseley's or modern form of periodic law. Same definition, but instead of atomic weight, you write atomic numbers. Same definition, instead of atomic weight, atomic numbers. Same definition. Physical and chemical properties of the elements are periodic functions of their atomic numbers. Physical and chemical properties of the elements are periodic functions of their atomic numbers. Okay, children, next. What is a group? What is a group? Definition. vertical columns in periodic table are called groups. Vertical columns in periodic table are called groups. Vertical columns are called groups. Next, periods. What are periods, children?
Horizontal
Horizontal groups in periodic table.
Horizontal. Don't say
Rows.
horizontal groups. Horizontal columns. Horizontal columns in periodic table are called horizontal columns in periodic table are called periods. Horizontal columns. Okay. Horizontal columns are called periods. Vertical columns are called groups. Horizontal columns are called periods. Vertical columns are groups. Okay, children. Before erasing this only, I will say here some more definitions I forgot to discuss, children. Here, whenever I am discussing dobernier law of triads, what is a triad? Group of three elements. Which has
Same property.
same properties. Group of three elements which has same properties. Group of three elements which has same properties. Group of elements which has same properties. Group of elements which has same properties. Next, what is octave?
Musical note.
Musical notes of any classical music. Musical notes of any classical music are called octaves. In our what is that? It's re, ga, ma, pa, dha, ni, sa. Our classical music, Indian classical music. Okay. Musical notes of any classical music is called octaves. Musical note of any classical music is called octaves. Musical note of any classical music is called octaves. Okay, children. Hope you are able to copy, children. So this definitions, if not, I will forget. That's why I came now only. So, children. Next, you understood all these things, no, children? Next definitions. Next, 10th definition. What are alkali metals? Metals of group 1. Metals of group 1 which form water soluble bases. Which form water soluble bases. Metals of group 1 which form water soluble bases. Metals of group 1 which form water soluble bases. Okay, lithium, sodium, potassium, rubidium, cesium, francium. Metals of group 1 which form water soluble bases. Next, what are alkaline earth metals?
Metals of group 2 which are found mostly in Earth's crust.
Very good. Metals of group 2. Metals of group 2 which are found in Earth's crust. Which are found in Earth's crust. Metals of group 2. You have to write metals of group 2 which are found in Earth's crust. Metals of group 2 which are found in Earth's crust. Example,
Beryllium, magnesium, calcium, strontium.
Barium, radium. Okay. So, children, next, metals of group 2 which are found in earth crust. Next definition, halogens. What are halogens?
Non-metals of 17th group which are found in seawater.
Very good. Non-metals of 17th group whose salts are found in seawater. Whose salts are found in seawater. Whose salts are found in seawater. Okay, children. Okay, whose salts are found in seawater. Non-metals of 17th group whose salts are found in seawater. Non-metals of 17th group whose salts are found in seawater. Next, noble gases. What are noble gases, children? Noble gases?
Elements of 18th group which have octet configuration.
Very good. Elements of 18th group. Elements of 18th group which has octet configuration. Elements of 18th group which has octet configuration. Elements of 18th group which has octet configuration and are highly stable. Without examples, no marks, children. Remember here what are the
Fluorine, bromine, iodine.
aspartate. Okay, aspartate. Here what are the examples? Helium,
Helium, neon,
neon,
argon,
argon.
krypton, xenon.
radon. Okay, sure. Noble gases. What are noble gases? Elements of 18th group. What are noble gases? Elements of 18th group. Next, what is atomic size?
Distance between radius and the outermost shell.
Distance between radius to outermost shell. Distance between nucleus to outermost shell. Okay, 1 second children, be online, sorry. Hello? Pump in, 68 will. Okay, children, distance between nucleus to outermost shell. Distance between nucleus to outermost shell is called atomic size. Distance between nucleus to outermost shell. Okay, children, this is atomic size. Children, distance between nucleus to outermost shell is called atomic size. It is measured in pico meter. 1 pico meter is 10 to the power of minus 12 meters. Next, metallic character or electropositivity or oxidizing character. Anything is same. Metallic character, electropositivity, oxidizing character or basic character, all are same. What is the definition? What is the definition? Tendency to
Give
Lose
electrons.
lose electrons. Tendency to lose or give electrons. Metallic character or electropositivity or oxidizing character, or basic character, everything is same, children. Okay, it is next non-metallic character or reducing character or electronegativity or acidic character. Tendency to
gain
Take
electrons.
electron.
tendency to gain electrons. Okay, tendency to gain electrons or take electrons. Next, ionization energy. What is ionization?
Energy required to remove electron from the atom.
Fantastic. It is the energy required to remove electron. Energy required to remove electron from outermost shell. 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 Electron affinity.
It is the amount of energy released when electrons is added.
Affinity. See, children, this is if you give energy, it will give electron. Here, if you give electron, it will give energy. So, electron affinity means energy released when you add electron. Energy released when you add electron. Energy released when you add electron. Energy released when we add electron. This is energy required to remove electron. This is energy released when you add electron. This is energy required to remove electron. This is energy released when you add electron. Okay, children. Next definition. Hope you are all copying, children. Please copy, children. You will not get this many definitions in the textbook, children. But they will ask in board exams, children. They won't show any compromise regarding that. 19th question. What is valence electrons? Valence electrons means
Electrons present in outermost shell.
Electrons present in outermost shell. Electrons present in outermost shell. Electrons present in outermost shell. Suppose if I am the student, if I am writing exam, I will write definition and I will say, suppose lithium is 2, 1. I will write 1 electron is in outermost shell. Like that I will write, children. So that I want to show that I know the subject very well. Next, valency. What is valency?
Combining capacity of an element is called valence.
Combining capacity of element is called valency. Combining capacity of an element is called valency. Combining capacity of an element is called valency. Example, same lithium only. Lithium is 2, 1. So its valency is +1 because it loses 1 electron to attain stability. It loses 1 electron to attain stability. Like that I will write, children. If carbon is there, 2, 4. So 4 is its valency. 4 is its valency. Like that, children. You have to substantiate your answers with various reasons, children. Okay. Next one. Okay, children. Next one. What is meant by atomic number? Anyone? What is meant by atomic number?
The number of protons and electrons present
Number of protons, don't say and, say or. Number of protons or number of electrons present in atom, because they both are same. Number of atoms or electrons. Number of atoms or electrons. Number of protons or electrons. Number of protons or electrons. Okay, 1 second, children. Be online. Hello. Oh, still not connection. 1 second. sorry children, number of electrons or protons present in an atom is called atomic number, children. Suppose if I say atomic number of, children see here, if I say atomic number of chlorine is 17, okay, atomic number of chlorine is 17, it means it has 17 protons and 17 electrons. It means it has 17 electrons and 17 protons. Okay children, next one, isotopes. What are isotopes, children? Anyone?
Same atomic number, different mass number.
Elements having same atomic number but different mass number. Elements having same atomic number but different mass number are called isotopes. 1H1 hydrogen, 1D2 deuterium, 1D3 tritium, or uranium 92-235, uranium 92-238, or chlorine 1735, chlorine 1737. So many isotopes are there, children. We have, okay, elements having same atomic number but different mass number. Elements having same atomic number. When isotopes you learn, compulsory you should know isobars also, children. What are isobars?
Elements having same mass number but
number,
different atomic number.
Same mass number but different atomic number. You studied all this in 9th class. Same mass number but different atomic number. One example, argon, calcium, 18, 20, but mass numbers are 40. Okay, now mass number I am saying from that time. Can anyone define what is mass number?
The sum of protons and neutrons.
Sum of protons and neutrons is called mass number. Sum of protons and neutrons is called mass number. Sum of protons plus neutrons is called mass number. So children, any definitions are left over, children? So yeah children, 3, 4, 5 definitions are still there, children. So 24. Okay, next definition, children. So in periodic table, children, I did not discuss what are lanthanides, what are actinides, what are S block elements. Definitions are there, children. All these are I have given in your books. If you want, you can say P block elements, D block elements, F block elements. All these definitions you should know, children. All this definition, anyone is asking, you should know, children. Compulsory you should know. Okay, D block elements, okay, and F block elements. What are these definitions? Still these are there, children. What are lanthanides? Lanthanides are F block elements. Lanthanides are F block elements starting with lanthanum. Okay, starting with lanthanum. Okay, and actinides are F block
elements starting with actinium.
Starting with actinium. Very, very good. S block elements are the elements. S block elements are elements
in which last electron enter into S block.
Very good. Whose last electron enters into S orbital. Whose last electron enters into S orbital. Whose last electron, first and second groups will come in this block, children. First and second group. P block elements whose last electron enters into P orbital. Elements in which last electron enters into P orbital. 13 to 18 groups. 13 to 18 groups. Example, whether they ask or not, we should say. Elements whose last electron enters into D orbital. D orbital. Okay, children. Here you will get 1B to 12B, 11, 12B, children. 1B in the middle, children. Like this, it will be there. No, we will study this. Here we will not study. These are B block 1B, 2B, 3B, 4B, 5B, 6B, 7B, 8B, 9B, all D block elements. F block elements whose last electron enters into F orbital. Lanthanides and actinides, examples. Down will be present now, children. They are F block elements. Lanthanides and actinides are example for F block elements. Okay. Next, representative elements. What are representative elements? Anyone?
S and P block elements.
Very good. S and P block elements are called representative elements. Very, very good. S and P block elements are called representative elements. Transition elements.
D block
D
elements.
and F.
No, only D, Nana.
Only
D block elements are called transition elements because they show they show transition in their properties, sudden change in their properties, transition in their properties, like they will get magnetism, they get conductivity, etc., etc. Okay, next, inner transition metals.
F block elements.
F block elements. F block elements are called inner transition elements. F block elements are called inner transition elements. Okay, children. Representative elements, transition elements, inner transition elements, S block elements. S and P block elements are called representative elements. Only D block elements are called transition elements. So only F block elements are called inner transition elements, children. Any more definitions are there, children, in our book? Means which we should know. Inner transition, I told. Yes. Any definitions, children? Anything left over? Let me know, children, anything is there in periodic table? Yes, yeah, children. One important definition I forgot, children. Most important. Metalloid. Very, very, very important. Metalloid. What are metalloids?
Elements with properties of metals.
Elements which have properties of both metals and non-metals.
Which show properties of metals and
Non-metals.
non-metals. Elements which show properties of metals and non-metals. Elements which show properties of metals and non-metals. Examples, some examples: silicon, germanium, arsenic, antimony, bismuth. Okay, silicon, germanium, arsenic, antimony, bismuth. Silicon, arsenic, silicon, germanium, arsenic, antimony, bismuth. These are called metalloids, children. Any more definitions are left over, children, for us? Any more definitions? Everything we studied, children. Everything we studied. Metalloids also I told of. Only just these are not there in your syllabus, children. Just anyway, I am saying chalcogens, nicogens. It's not there, children. Just I am saying 16th group elements are called chalcogens. 16th group elements are called chalcogens. Okay, argon, sulfur, selenium, tellurium, polonium. Argon, sulfur, selenium, tellurium. Nicogens.
15th group elements.
15th group elements are called nicogens. See, 15th group elements are called nicogens. What are nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, children. Last definition, children. Pico meter. What is pico meter?
The instrument used to measure
Is the unit
atomics.
used to measure
Atomic size.
Atomics of the unit
used to measure atomic radius. Units used to measure atomic radius. Units used to measure atomic radius. Units used to measure atomic radius. So how many definitions we studied, children? 37 definitions we studied in periodic table. I thought it is small, but suddenly so many came, children. So children, how many we studied? 25 definitions in chemical reactants, 25 definitions in acids and bases, 37 definitions in periodic table. In carbon compounds and the metals and non-metals also, so many definitions are there. All definitions, all reactions, if you know, half of the subject is over, children. Like this you have to read, children. Okay, thank you so much, children. Evening no class, please don't come, children.